Hello everyone. In today's video, we are going to learn geometric sequences. Till now, I have covered linear sequences, quadratic sequences, and cubic sequences. In this session, we'll learn how to find the nth term expression of a geometric sequence, also known as exponential sequence, which is a part of the IGCSE Mathematics syllabus. So stay tuned till the end of the video and let's do some math. Cubic sequences. In all the other previous videos when we covered linear sequences, quadratic sequences, and cubic sequences, first we identified that the given sequence is a particular type of sequence. Like linear sequence, the first difference is common. In quadratic sequence, the second difference is common. In cubic sequence, the third difference is common. Does that mean in geometric sequence, the fourth difference between the two successive terms is going to be common? Or there's something else? So let's figure it out and do geometric sequence. Let's check with an example. Question number 1, it says find the next two terms of the given sequence. So we can clearly see that it's a increasing sequence. So -8, you add 4, you will get -4. -4, you add 2, you will get -2. You add 1, you will get -1. Now from 4 to 2, it is decreasing. So it's not increasing like any other sequence. So now this is -2, then this is -1, then this is +1. So I think this is not going to work out at all, because if it's an increasing sequence and if it is linear, quadratic, or cubic, even the differences should increase by a certain interval, which is not happening. So let's check the other way out. We can see that -8 to -4, if we check -4 by 8, -4 by -8, we are getting 1 by 2. If we will check -2 by -4, we are getting 1 by 2. And if the last one, if we check -1 by 2, -1 by -2, we are getting again 1 by 2. So we can clearly see that it is increasing by a common factor, which is 1 by 2. That means if I multiply -1, which is the fourth term, with half, I'll get my next term, that is -1 by 2. So my next term will be -1 by 2. And if I multiply -1 by 2 with 1 by 2, which is our factor, common factor, I'll get -1 by 4. So -1 by 4 is my next term. So -1 by 2 and -1 by 4 are the next two terms, and we figure out that in geometric sequence there is no common difference. There is a common factor, which is known as common ratio. Common ratio R, and R is actually A2 by A1, or R is equals to A3 by A2, or any successive term divided by the previous term, that is common ratio. So let's check the other question now. Question number 2, it says find the common ratio of the geometric sequence and then find the next two numbers in the sequence. So let's check. We can directly find the common ratio. Common ratio R, that is A2 upon A1. So we can simply write 6 by 3, that is 2. So 2 is the common ratio, and we can also clearly see that the terms are increasing with a multiple of 2, 3, 6, 12, 24. So the next term will definitely be 12 into 2, which is, sorry, 24 into 2, 12, because 24 is already given. So 24 multiplied by 2, that's 48. And then 48 multiplied by 2, that's 96. So these are the next two terms, 48 and 96, and that's our answer. Moving on, let's check another question. It says write the function rule for the geometric sequence. So when they are saying function rule for the geometric sequence, we have to frame the expression, just like the nth term expression, which helps us to figure out any unknown term. So like the 4 terms are given to us, all of a sudden if I have to find the 100th term, so there should be an expression where I can substitute the value 100 and figure out the 100th term. So let's check again common ratio. R, that is A2 by A1, so 20 by 8, that is 5 by 2, like 4 2s are 4 5s are, that's how it is, 5 by 2. Now we have to frame the formula, so that is, this is the formula, an equals to a multiplied by r raised to n minus 1. So this is the geometric sequence formula that we have to remember, and this is the function rule. Let's check whether this is correct or not. So we can pick a random term. Let's say we need to verify the third term. The third term is 50. We'll substitute 3 in this expression and check whether we are getting 50 or not. So A3, A is the first term. So first term is 8 multiplied by R, that is common ratio, 5 by 2, raised to n minus 1. This is the third term, so 3 minus 1. So R multiplied by 5 by 2, the whole square. This can be written as 8 multiplied by 25 by 4. 4 ones are 4, 4 twos are 8, and 2 into 25, that's 50. And this is exactly the third term. So verified. So that's how we have to use an equals to a r raised to n minus 1, where a is the first term and r is the common ratio. Let's check the last question. These type of questions are also asked in the examination, where the nth term expression is already given to us, and we have to find the unknown terms. It says find the first, second, fifth, and ninth terms of the sequence. So let's check. If I have to find the first term, I have to find a1. So a1 will be 5 multiplied by 3 raised to 1 minus 1, that is 5 multiplied by 3 raised to 0. Any number raised to 0 is always equals to 1. So this is going to be 5 into 1, that is 5. Let's check the second term, a2. So a2 will be 5 into 3 raised to 2 minus 1, that is 5 into 3 raised to 1. 3 raised to 1 is 3 only, so 5 into 3, that is 15. You have to check the fifth term now. a5, that is 5 into 3 raised to 5 minus 1, so that is 5 into 3 raised to 4. So 5 multiplied by 3 raised to 4, that's 81. So this is going to be 81 into 5, 405. 81 into 5, 405. So this is the fifth term, this is the second term, this was our first term. Now we need to find one more, the ninth term. So let's check a9. a9 is going to be 5 into 3 raised to 9 minus 1, that is 5 into 3 raised to 8. So we can do this in calculate directly. 5 multiplied by 3 raised to 8, that is 32805. 32805, and this is the ninth term. This is the first term. This is the second term, 515. This is the fifth term, 405. And the ninth term, 32805. So with this, we have covered all the types of sequences. If you need any help, or if you want to understand any particular type of question, you can tell me and in the comment section, and I'll get back to you. That's all for this session. I hope this was helpful to everyone. Bye.